We're looking at Leetcode number 141, linked list cycle. This is a classic linked list problem, very classic pattern, definitely one to know, definitely shows up all the time. Highly recommend to be familiar with this pattern. Also, once you know this pattern, you can solve many other questions that come up with linked lists and even other types of data structures that don't involve linked lists but follow the same principles. So what are we doing here? We're going to be given a linked list, and we want to detect, is there a cycle in this linked list? And if it is, we return true, and if there's not, we return false. So here we have 3, 2, 0, minus 4, and we can see that if we go from 3 to 2, 3 to 0, to minus 4, and then this goes back to 2, and we can see that there's a cycle here. We return true. This is also going to return true because we have a cycle here. This 2 pointer points back to the 1. And then here we have a 1. It doesn't point to anything else, so it's false. And so let's think about this. There's a couple different ways to approach this. Let's go ahead and move over to the conceptual overview, and we have 3, 2, 0, minus 4. So here we have a list with 3, 2, 0, minus 4. Let me write this again and just give a little more space. So we have a list with 3, 2, 0, minus 4. Okay. And now this 4 points back to this 2. This 4 points back to this 2, and that's where our cycle is. And so what's a brute force way we could do this? Well, what we could do is we could say if there's a cycle, then what we could say, the number will have already been seen, right? So let's say we had pushed all these numbers into an array, and we had 3, 2, 0, minus 4. We could even just put all these nodes in that array, and then when we come back here to 2, we can say, well, this has already been seen. It's already in there, and if it's already in there, then we have a cycle. That is one way to do it. The only issue with that is we're going to create a bunch of extra space, and it's going to also be extra time, because if we have an array, which is a contiguous structure, every time we want to check if something's in there, we're going to have to iterate over that entire array, worst case. So immediately we're looking at linear space, and we're looking at quadratic time, which is not great. So what's another way we could do this? And that is using the method using 2 pointers. Okay, and this is a very classic pattern, definitely one that you want to know. And the idea is you're going to have 2 pointers. You're going to have a fast pointer, and you're going to have a slow pointer. And every time you iterate, the fast is going to move 2 steps, and the slow is going to move 1 step. Okay, so let's just kind of step through this. On our first iteration, the fast will move 1, 2 steps. The slow will move 1 step. Fast will move 1 and 2 steps. It'll come back here to number 2, and slow will also move over here to 0. And then fast will again move 2 steps back to the minus 4, and slow will move here to the minus 4. And when we get here, if these 2 nodes are equal, then we have a cycle. And if they're unequal, then there's not a cycle, because they'll never actually cross each other. Okay? And so that's it. That's how you detect cycles in linked lists. It's very simple. You just want to use 2 pointers, 1 fast and 1 slow. And if any time during that traversal, as they're going through the list, 2 nodes intersect, both those pointers point to the same node, then we have a cycle. That's where that cycle is. Okay, so let's go ahead and jump into the code. Okay, so all we want to do here is we just go ahead and get a fast pointer and go ahead and set that to the head, and we get a slow pointer and set that to the head. Okay, and now we just want to do while fast and fast.next. Okay, and now what we're going to do is we're just going to update fast and slow. So fast is going to equal fast.next.next, and slow is going to equal slow.next. And if fast equals slow, return true, else we'll break out of this loop. We'll get to the end of the linked list and we'll go ahead and return false. Let's go ahead and run that. And yeah, we're good. Okay, some things to think about here. Now, why fast.next? Right, this line right over here. Why do we have to do that? Okay, let's go ahead and jump back to the whiteboard here. So we need to make sure that we get to the end of the list and that everything that we're iterating over, we don't have a null value on the next. Okay, so let's say we have here 1, 2, 3, 4, 5, and 6, right? And this is going to point to null, and there's no cycle in this, right? And so now we're going to have a fast and a slow. And so let's just kind of walk through this. So here fast is going to increment 2 and slow is going to increment 1. We're going to check is fast true and is fast.next true. Okay, if they are, go ahead and increment fast twice to the 5 place and increment slow once. Now we check is fast true and is fast.next true. If it is, then this fast can increment to this null. That's where it's going to be. And then this slow will go ahead and increment over here. And then fast is not true, and we can go ahead and exit out of the loop. Okay? And so the reason we want to do fast.next is that when we get to the next iteration, we're not calling fast.next on a null value. That's the main point of it, because if we do it the other way, we're going to be calling fast.next on null, which will throw an error. And so that's why we are on this line over here, we're using while fast and fast.next. Okay, so just something important to remember when you're using 2 pointers. This is a pattern that you want to have memorized. You want to just know this. It's very common in a lot of linked list questions that you're going to have to traverse, find a cycle, find the start of a cycle. It just comes up all the time. So this particular pattern, it's just, it's probably good to just have it memorized. That way when it comes up, you don't have to think about it too much. Okay, that is linked list 141, or that is Leetcode 141, linked list cycle. Hope you enjoyed it, and I will see you on the next one.